Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we don't have a problem today. Today we are continuing our discussion of meteorology. And meteorology is the study of the atmosphere, and the atmosphere is comprised of air. So we really want to talk today about air, or we could say this: the composition of the atmosphere. What's in the air? Take a look at this graph. Now, what most people think is that air is primarily made of oxygen. And that's wrong. As you can see, oxygen is about 20%. Nitrogen is the biggest component. I bet you didn't know that. Nitrogen, the gas nitrogen, has the biggest. It's like 79%, right? Oxygen is about 20%. You do the math here, that's 7, 20, 79, 20, that's 799. So there's only 1% of the other gases present. But those other gases matter. So oxygen is really important, right? We breathe this. By the way, if our oxygen was much higher, if it was 21 or 22 or 23%, probably like the forests would all burn up, because oxygen is what it needs for like burning things. It's what we breathe. So it's actually very advantageous as it's not higher and actually not lower. So it's like the perfect amount. And nitrogen is a kind of an inert gas. It does some things. Yeah. Now what we want to spend the balance of our time on is talking about sort of the other gases that are present in the atmosphere that are important from, say, a meteorological stand. And now what we want to do is we want to spend some time talking about the minor gases, the 1%, and especially the ones that are important meteorologically, is that a word? That has to do with the weather. That's what I'm trying to say. So let's talk about those gases. The first one we'll talk about is carbon dioxide, all right? Carbon dioxide, you know this, you breathe out carbon dioxide, the plants breathe in the carbon dioxide, that's the photosynthetic process. You know the gig, right? It's at about 397 parts per, is it million or billion? I think it's million. It's parts per million. All right, so about 400 parts for every million. So if I took 1 million molecules of this, there'd be about 400 of them that's CO2. Now, why is this important? Of course, we don't live without CO2. CO2 is super duper important because we eat plants. And if the plants have no CO2, they die. All right? But here's sort of a problem. Take a look at this graph right here. This is the graph of carbon dioxide, the amount of carbon dioxide in the Earth's atmosphere over time. And since, 1960, and you can see that it starts at about 310, and now we're up to 400-ish. And this is a concern. So this actually leads to a very important discussion that we're going to have later, that it could be impacting climate change and changing our climate. We talked about climate in the last video. And maybe that's causing a problem with our climate. So change of climates creates all kinds of issues, which we'll get into later, because carbon dioxide is what we call a greenhouse gas, which potentially causes the Earth's temperature to rise, which is causing some issues, okay? But anyways, carbon dioxide is super important, and there's some concern that the rising amount pictured in the graph is an issue. The second one that we're going to talk about is water, or I'll say water vapor, right? All right. This represents about 0 to 4% by volume of gas. So there's a lot of water vapor. It's a gas, I guess, and it depends on where you live. We live in Houston. We're going to have a higher percentage of water vapor in our area than, say, where I used to live in Colorado. I used to live in Colorado. It's a dry climate. It's going to have a much lower percentage. Now, there's something you might realize called relative humidity. You might say, wait a second, the relative humidity is 88%. But you're saying it's only 4%? Actually, it's 4% of the total air. We'll learn more about what relative humidity is later. But water vapor is huge. Of course, what's the importance of this? Clouds, rain, all that stuff. That's just water vapor, right? And how it moves, it's really important. It's an important thing for like heat transfer as it moves energy around the Earth. Evaporation, condensation. So water vapor is such an important thing and part, if you will, of our atmosphere. The next one is something called an aerosol, which I always spell wrong. E-E-R-O-S-O-L. Aerosols. Now what aerosols are, now you might think I've got an aerosol spray or something like that. Like here, I've got a bottle. This is an aerosol spray. It's my glass cleaner here for the glass board. And But aerosols are actually small solids in the air. Just think dust. So small pieces of dust or small particulates of something, and it's floating around in the air. And solids can float in the air if there's like some wind and stuff like that. You've been on a dusty day and seen what that looks like, I'm sure. So they're small aerosols. Now, one of the things that makes these like super important is they're super important for clouds. You see, water, when it evaporates, it needs something to condense onto. So the water, as a gas, needs some little piece of dirt. That little piece of dirt or dust, it condenses on, and that makes a raindrop. So the clouds and the little dust particles are necessary, and there's lots of aerosols that we could use in our own world right now. I mean, it depends on when you watch this, but we're experiencing the whole COVID crisis, and they talk about aerosol, the virus being carried by aerosol, little solid particles when we sneeze, kind of nasty. And now it contains the virus, and then we breathe it in, and then that's all bad, right? And then the last one we'll talk about is something called ozone. Now, ozone, as it turns out, is a weird chemical. By the way, ozone is like oxygen with a 3, O3. Ozone's kind of weird in is that it's a pollutant at the surface of the ocean, surface of the land. So if there's a lot of ozone right here in my room right now, it's bad. It's very caustic and it can destroy things. Yet, you may have seen this, there's actually ozonators where you can take ozone, it kills things, it's actually a disinfectant, and I can bomb a house with ozone and I can kill a lot of creatures. It's a poison, really. And but it's actually not a bad way to do things. Is I can ozonate a certain area, and it'll take like smoke smells out. It's pretty powerful stuff. It's pretty cool. But you don't want it to be coming out and breathing this in. But then you probably heard of this. There's something called an ozone layer. So way up in the atmosphere, we're going to talk about the atmosphere way up in a little bit, a couple of videos, there's ozone. And the ozone covers and protects the Earth from harmful ultraviolet rays. You see, here's the Earth, we got the atmosphere around the Earth, we got sun's rays. A lot of those sun's rays, some of them make it through, but the reality is that a lot of them bounce off. And one reason they bounce off is the presence of ozone in the upper atmosphere. And this is a big issue because there is some concern that, and it's been totally proven, is that some of the things that we as humans have made, some of our aerosol sprays, that we use, have, particularly like with some gases that we use in our air conditioning units, it sends some particles up there, and they kind of eat away and chemically react and change the ozone into something else. And then they become holes in the ozone, like right here, and then that sunlight, when it goes through here, it goes right through here, and you don't have that bouncing effect. So anyways, it's important to understand ozone is sort of a weird chemical. It's a pollutant and a dangerous thing on the surface. You don't want to breathe it. It's not good for humans. But yet it's important for the planet. So kind of a weird deal. We don't want ozone to go away because it's important, especially up here, and we can use it sparingly down below. So this is what gases make up the atmosphere. Remember, 79 nitrogen, 20 oxygen, and then the 1% of these other things. Actually, there's one other gas that's present I didn't mention. We saw it there. There's one called argon. The reason I don't mention argon at all is it's a boring gas. It doesn't do anything. It's a noble gas from the periodic table, and so it's just there and doesn't add or subtract. It doesn't have any kind of big implications. So Houston, composition of the atmosphere. We don't have a problem. We'll see you in class.